Okay, let's dive right into this. Welcome to The Explainer. Today, we're cracking open a truly fascinating chapter from Peter Jaworski's book, Real-World Bug Hunting. We're going to explore a technique that sounds incredibly complex, but is actually a brilliant digital heist blueprint, HTTP parameter pollution. If you've ever wondered how hackers find vulnerabilities hidden right in plain sight within the web addresses we click every single day, you are in the exact right place.
So, let's start with a foundational question. What actually happens when a website trusts you just a little too much? You already know that every click or form submission hands parameters over to a server, but what if that server just blindly trusts whatever you hand it, without validating if those instructions actually make sense? Well, that blind trust is the exact loophole we're exploiting today.
That brings us to the core concept of HTTP parameter pollution, or HPP for short. Simply put, it's the process of manipulating how a website treats parameters by injecting extra ones that the site trusts, which leads to unexpected behavior. Basically, you're sneaking additional hidden instructions into a web request. And because the target website trusts the format of your request, it accidentally executes actions it never originally intended to.
Here is our roadmap for the explainer today. First, we'll define parameter pollution, explore server-side and client-side HPP, dig into some wild real-world bugs from HackerOne and Twitter, and wrap up with the bug hunter mindset.
What is parameter pollution? The bank transfer analogy.
Let's picture a standard bank transfer. A normal URL might instruct the server to move funds from account 12345 to account 67890 for an amount of $5,000. Easy enough, right? But what if an attacker injects a duplicate parameter at the very end, say, and from equals ABCDEF? Well, a poorly configured server might actually prioritize that second parameter. It processes the transfer, sure, but it pulls funds from the attacker's chosen account, ABCDEF, instead of the original one. It's like digital sleight of hand. You've just tricked the system using a simple text addition.
Section 2. Server-side HTTP. How different tech stacks get confused. Now, what's really interesting about this is that this is where the detective work really begins. Because the back-end code is completely invisible to users, finding these bugs requires a lot of experimentation. There is absolutely no universal rule for how servers handle duplicate parameters. Based on some great research by Luca Caratoni and Stefano De Paula, different technologies react completely differently to multiple parameters with the exact same name. For example, PHP and Apache, they'll use the last occurrence they see. Apache Tomcat and JSP, they use the first occurrence. And ASP and IIS will actually merge them and use all occurrences. So you really have to experiment to figure out which technology you're dealing with and exactly how it gets confused. Section 3. Client-side HPPP, the browser battlefield.
Okay, let's flip the script for a second. Instead of the manipulation being hidden away on a remote server, client-side HPP happens right on the user's end. Notice that %26 right in the middle of this encoded URL? That's the URL encoded version of an ampersand symbol. Now, if you just used a normal ampersand, the server would spot it as a new parameter immediately, and might just drop it if it wasn't expecting it. But by encoding it, you're smuggling a hidden parameter, in this case, action equals edit, right past those initial security checks, packing it tightly inside the very first parameter.
And here is where the magic happens on the client side. When the server processes that smuggled input using a standard function like HTML special chars, it converts the %26 into its safe HTML entity, the ampersand. This accidentally creates a brand new, fully functional link containing your smuggled action equals edit parameter. The browser reads that newly formed link, and suddenly, boom, you've altered the application's behavior right there on the page.
Section 4. HackerOne Social Sharing Bug, Manipulating Social Trust.
So HackerOne had these buttons that let you share their blog posts straight to social media. Pretty standard, but a hacker realized they could tack extra parameters onto the HackerOne blog URL itself. By appending an extra U parameter with an entirely different web address, they forced Facebook's sharing mechanism to prioritize the attacker's link instead of HackerOne's original one. And if they used the text parameter, they could literally change the default text that popped up when someone tried to share the post on Twitter. It's an absolutely brilliant manipulation of social trust, redirecting users to anywhere the attacker wanted.
And for identifying this relatively simple, low-difficulty bug back in December 2015, HackerOne paid out a $500 bounty. It just goes to prove that even straightforward parameter pollution vulnerabilities are highly lucrative for bug hunters who know exactly where to look.
Section 5. Twitter Notification Vulnerabilities. The digital detectives strike.
Check this one out. When hacker Mert Tachi was unsubscribing from Twitter emails, he noticed a user ID parameter, or UID. He tried changing it to someone else's ID to maliciously unsubscribe them, but Twitter threw an error because they also had a security signature parameter, the SIG, that validated the ID. Now, most people would just stop there, right? But Mert injected a second UID parameter. The server validated the security signature against the first UID, passing the security check. But the backend code that actually processed the unsubscribe action, it used the second UID. He successfully unsubscribed another user and earned himself a $700 bounty. And this brilliantly illustrates our next vulnerability, which targets an early version of the Twitter Web Intents feature. This allowed users to like a tweet or follow an account directly from a third-party web page, creating a little pop-up window so you never actually had to leave the site you were currently visiting.
Hacker Eric Rafaloff started poking around these web intents pop-ups. Now, a normal, intent URL only needs a tweet ID parameter. But Eric decided to inject a completely unexpected parameter into the URL, and screen name equals Eric R Test 3. By smuggling this into a like pop-up, he completely tricked the interface. The pop-up still asked the user to like the targeted tweet, but it displayed a follow button for his entirely unrelated test account right next to it. He essentially manipulated the application's logic visually, simply by polluting the parameters.
Section 6. The Bug Hunter Mindset. Persistence and Trial and Error. If you want to spot these bugs out in the wild, here's exactly what you need to be looking for. First, always look for ID-like values in URLs, just like that UID in the Twitter example. Second, thoroughly test social media sharing links as they constantly rely on dynamic URL generation. Third, check any parameters that use auto-incremented integers. And finally, keep in mind that finding a parameter pollution bug often points to much broader systemic issues on the platform. Where there's one logic flaw, there are usually more waiting to be found.
This quote from Peter Yaworski perfectly captures the essence of this entire topic. He says, discovering HPB vulnerabilities requires thorough testing more so than for some other vulnerabilities. This means we can only infer how sites handle the parameters we pass to them. Because the server code is essentially a black box, totally hidden from view, your very best tools are curiosity, persistence, and, honestly, a whole lot of trial and error.
We've covered the hidden mechanics, the required mindset, and some absolutely incredible real-world examples. So the crucial point to end on is this: knowing how easily massive, secure servers can be completely confused by just a simple extra string of text, will you start looking a little closer at the URLs you click every single day? The web is built on trust, but as we've seen, trust is easily manipulated. Keep learning, stay curious, and definitely keep an eye on those parameters.